All right, so like I said, I found a better way to do those problems with the horizontal asymptote. So let's write that down. I won't write anything there for section because it's section 3.7, but it's a better way, at least for me anyway, to find the horizontal and then asymptote. Again, I don't know why the book doesn't show you this way, but there's a lot of teachers. Again, like I said, I probably watched 4 videos yesterday where different teachers were showing how to do this. So we want to find the vertical or the horizontal, asymptote. So that's going to be like y equals something. There's 3 different ways you need to examine your function. Okay, so you're going to look at your function. And I'm going to do some of these problems for you or with you. We'll say it that way. But there's 3 things that you need to look at on which one you're going to use. So on all of these, you have a numerator and a denominator, a top and a bottom. Okay, we'll just call it top and bottom, just make it a little bit easier. And so what you're going to do is you're going to compare the degree. Do you remember what back maybe in Algebra 1, you learned the degree of a polynomial? Does anybody remember that? So if I had 3x squared minus 2x plus 1, what's the degree of that polynomial? It's just the highest exponent. So what's the highest exponent? It's a 2, right? See the exponent right there? Shh, come on now. I gave you time to mess around. Now it's time to listen. All right, so you look for the highest degree, the highest exponent on here, okay? And the highest exponent is right there. It's an x squared. So this is be a second degree polynomial. All right, what if you had something like this? What if you had 3 plus 2x minus x cubed plus 5x to the 4th? Okay, what if you added something like that? What's the degree of that polynomial? It's 4. Okay, that's the highest. It doesn't matter that it's on the end, doesn't matter that it's at the beginning or if it's in the middle or anything else. 4 is bigger than 3. What's the degree of this term right here? It's x to the what? To the first. There's even a degree to this x or to this number right here. Because you could write it with an x. How could you write a 3 and include an x? Is 3x the same as 3 though? What is it? To the 0, that's right. X to the 0. Because what is x to the 0? X to the 0 is a 1. 1 times 3 is 3. So you can look at all the exponents. You got a 0, you got a 1, you got a 3, you got a 4. Which one's the highest one? 4 is the highest one, so that's the 4th degree. So when I talk about the top degree and the bottom degree, that's what I'm looking at. I'm looking at the top of the function. Okay, these are rational functions, right? What is that word? Did I do this yesterday? Or whenever I taught this. It's a rational function.
Immediately. Any students that were just with Mrs. Weber, please come back to the office immediately.
All right, so.
If you were with her last period, thank you.
Okay, so if it's rational, what word is in that word? I mean, there's probably several words that's in there, but what's the math word that's in here? It's ratio. What's a ratio? Ratio is just a comparison of 2 things. Right? I think we talked about that. I remember somebody saying something, it's a comparison, but it's basically a fraction. Okay, ratio is a fraction. So that's what we're doing. We're trying to find the horizontal asymptote of rational functions. Okay, so fractions, top, bottom, numerator, denominator. Everybody got that? So all of these problems that we've been doing with these asymptotes are rational functions. So let's write it out here. So when you have the top degree being less than the bottom degree, and this is just so nice. And I did watch a couple of videos where they went through and they gave you an explanation of why this is true, which is really good. I'm just going to show you what it is. So if it's less than, here's what the this is what the horizontal asymptote is. It's always y equals 0. All right? So every time you see a fraction, when the degree of the top one is smaller than the degree of the bottom one, what's the horizontal asymptote? It's just y equals 0, which means what? What does that mean to us? Well, it's going to, the y equals 0 is actually the x-axis, isn't it? Because it crosses the y at 0. So when the top degree is smaller than the bottom degree, so for instance, if I had x to the 4th over x to the 5th, right? What's the horizontal asymptote of something like that? It's 0. Y equals 0. It's not just 0. Remember, it's an equation of a line. That's what we're trying to find. Trying to find the equation of a line, all right? And the equation of the line is y equals 0. Everybody got it? So this is going to have a horizontal asymptote of the x-axis, or y equals 0. It is easy, okay? We got 3 of them, though, because we have, why do you think we have 3 of them? Because we have the top could be what? Less than the bottom, or the top could be more than the bottom, greater than the bottom, or the top could be equal to the bottom, okay? We're going to do that one next. And we're going to do some of these problems that you had for homework just to show you how it works and how easy it is. See, next year I'll look like a genius and I'll be able to teach this and say, oh, here's a nice, easy way to find. But now, in here, I had to go through all this stuff because I've never done this before. I've never seen this in my life. Not one time have I ever seen this until yesterday when I watched this on YouTube. All right, so now we're just gonna rewrite these. The top, that's supposed to be a TOP. Top degree is equal to the bottom degree. This is probably an easier way to do this, but that's okay. All right. When it's equal, then what we do, and I'll do some problems as an example, all right, but I'm just going to write this down right now. We divide the coefficients. Yes.
When you're comparing them, you always choose the highest one. Like if there's multiple, you always choose the highest one from the top and the highest one from the bottom. So
yes, because that would be the degree of it. That's right. So if this was the numerator, then the degree would be a 4, right? And if that was the denominator, then the degree would be a 2. Exactly. So what we're going to do is we're going to divide the coefficients. And that is going to give us the y. I always keep saying the y, the horizontal asymptote. Okay? I'll show you that in a minute. All right, number 3. So if the top degree, what's the other choice now? We got less than, we got equal. It's greater than, okay? So if the top degree is greater than the bottom degree, this one's kind of nice. There is no horizontal asymptote. Okay? It doesn't exist. All right, so it's a graph that does not have a horizontal asymptote.
you just keep the vertical one and you just put no horizontal.
Yeah, that's right. Okay, you'd find the vertical if it has a vertical, and you would just say it has no horizontal asymptote. Everybody with me on that? All right, let's do some of the problems. Coefficient is a number in front. Like that's a 2. Like the coefficient of that would be a 5. All right, well, I'll show you what I mean when they are the same. And the first one we do is going to be like that. Everybody write that down? All right, that's pretty nice, okay? You just got to remember which one's which. If you can remember which one's which, it's pretty simple. The only one you really have to do some math with is which one. If the top degree and the bottom degree are equal to each other, right? That's the only time you really have to do some math. Okay, if the top is smaller, then it's y equals 0. If the top is bigger, then it's just no horizontal asymptote. Okay, the only time we have to do anything, really, is when they're the same degree. All right. So let's just do a few of these. So number 14, this is right from your homework. 14 says f of x is equal to 2x over x plus 4. All right. So what do we got here? What's the degree of the top one? It's 1, right, because it's x to the first. It's x to the first. What's that? When it's just a constant. All right, like this 4 right here. See, it's 4x to the 0. But x is bigger than x, or x to the first is bigger than x to the 0. So the coefficient, or the, the degree of the top is 1. What's the degree of the bottom one? It's also 1. Okay, so they're the same. So what did my little chart tell you to do? Divide the coefficients. So what's the coefficient of that? It's 2. What's the coefficient of that? It's 1, because there's a 1 in front of it. It's the number that's multiplied by it that's out in front of it. So there you go. So how do I write my horizontal asymptote? Remember, this is a line. It's a horizontal line, so how do I write that? Just y equals 2. And that's it. That's how you find your horizontal asymptote. Say that? Right, that's what I'm saying. That's why I got so excited about it when I saw it. I thought, oh, they're going to love this. All right. So now this problem does ask also for the vertical asymptote, doesn't it? So which one's this one? We'll just call it HA for horizontal asymptote. It does ask for the vertical as well, right? How do you find the vertical asymptote? Remember, it's 2x over x plus 4. What do we look at? We look at the denominator, right? Yeah, and so we just go x plus 4 equals 0. And technically, it's not equals 0 because you're trying to find out what x cannot be, but that's what our vertical asymptote is going to be. So you subtract 4 from both sides, so x equals negative 4. That right there is our vertical asymptote. So if you were to graph this, if you wanted to start off graphing it, knowing what your asymptotes are really help a lot. So the vertical one is negative 4. So 1, 2, 3, 4. So this is your vertical asymptote. And what is this one? Y equals 2. That's your horizontal asymptote. So it's going to look like this. Now, it is a positive, right? It's not a negative. It's a positive right here. So what's it basically going to look like? Now, it's not all that specific, but what is it basically going to look like? What do these rational functions look like? Yeah, one goes like this, and the other one goes like that. So if you were to graph that, right, on Desmos or something, you would see that it looks something similar to this. All right? So knowing the horizontal and vertical asymptotes are really helpful when you're doing these things. Does that make sense? So you kind of know like where your curve is approaching and all that kind of stuff. All right? Ready to do another one? Let's do another one where they're not the same. 15. 15 is a good one. So 15 is f of x equals x squared over x plus 6. All right, so there it goes. Let's do the vertical first, okay? The vertical asymptote. Okay, I'll put VA. So again, what do we do to find the vertical asymptote? We take the x plus 6 and we do what to it? Set it equal to 0. So you solve for x equals negative 6, and that's your vertical asymptote right there. Again, what does that mean? It means it's a vertical line that goes through the x-axis at negative 6, okay? I'm not going to graph all of these. It doesn't ask you to do it, but I just want you to see the importance of finding the horizontal and vertical asymptotes. All right, now let's do the horizontal one. Horizontal asymptote. So what do we do? What's our little rule? Little 3-point checklist thing. Look to see the degree. What's the degree of the top one? It's 2. What's the degree of the bottom one? It's 1. So this is bigger than this one. So what did it say when it was bigger? That's right. There's no horizontal asymptote. Okay? Pretty easy, right? Yeah. I do too. Believe me. I would have saved a day or two knowing this. And the book doesn't mention this at all. It's weird, doesn't it? All right. But again, I've seen a bunch of videos where people do this, and I've seen some where they explain it fairly well.
So maybe
But
it's kind of like a, not like a cheat code, but like they don't want kids to do it.
maybe.
Because like the book is telling us a way that works every time, but this might not work every time.
No, I think this works every time. But I watched this other girl's video. You couldn't see her; you just see her writing and stuff. And she's really, really good. She explains things just so easily, and it just makes complete sense. And she was showing like where this comes from. It was different than what the book explained, and so I think her explanation would be a much better explanation in the book than what they do. But anyway, this works for us. That's all we care about anyway, isn't it? It's getting the right answers. I mean, it shouldn't be, but it kind of is. So this works pretty good. Maybe after we're done this, I'll look to see that other video where they explain it a little bit if we have time. We probably have time because this might be the last one I do, because this one is it's going to have the it's going to be the other way around. Okay, the top one's going to be smaller than the bottom one.
So how would you graph that horizontal asymptote?
Yeah, well, it could be a thing called a slant asymptote, and considering I'm doing, let me ask you this. I don't know. Do you guys remember doing anything like this in Algebra 2? Where you had like, I don't know, 2x cubed minus 5x squared plus 3x minus 1. You guys, right? And you said, how many times does this go into this? Okay. All right. I didn't know if you guys did that or not, because to do that slant asymptote, you got to do some division like this. So maybe tomorrow, maybe we'll do some that has a slant asymptote, since you have learned how to do this. Well, at least you were taught it. Don't know if you learned it or not, but maybe it'll. Is it the same thing? Is that what you said? Same thing? What's he saying? Oh, he failed it. Everybody else passed it?
Yeah.
All right.
Sam fell asleep during the quiz, actually. I fell asleep
During a quiz?
15 minutes like that.
All right, let's do this one. You ready? Okay, write this one down. This is 16. This will be the last one I do, and I'll let you do the other ones on your own, okay? Because this hits all three of them, the first three. So 2x plus 1, x minus 5. All right, first thing, let's do the, did we do vertical on the other one? We did, didn't we? Yeah. All right, let's do the vertical one on this one as well. Okay, so vertical asymptote. So now, the way it's written is actually a good way to figure out what the vertical asymptote is. Is this the way it's written in the book? Somebody have the book open? It's number 16, section 3.7. Do you have it?
It's like page 186.
186. Yeah, it's page 186. Is it written just like this? Okay, because sometimes they write it. Excuse me. They write it and you have to factor it. I don't think you have to factor this one. All right, so we're just going to keep it like this. So how would I find the vertical asymptote on this one? Well, that's going to make it more complicated. It's a lot easier the way it is right now. Set both of these things equal to 0, correct? So we're going to take, because if this is 0, it doesn't matter what this is. 0 times anything is 0, correct? And that'll give us an undefined, right? And that's what we want. We want to find out where is it going to be undefined. All right, so I could set this equal to 0, and I could also set what else? I could also take the x minus 5 and set that equal to 0, because if this is 0, it doesn't matter what this is. 0 times anything is 0. Again, it gives us another place where it could be undefined. So actually on this one, you're going to get 2 vertical asymptotes on this, all right? So subtract 1, divide by 2, so what's x? Negative 1 over 2, add a 5, x is 5. And so those are your 2 vertical asymptotes, all right? And it's nice to have them separated like this in parentheses, okay? Because you may have some, let me see. Yeah, number 17, where you're going to have to do a little factoring. Do you remember doing that in Algebra 2? You probably did a lot of that in Algebra 2. You should have. We're going to do some more. I think it's in the next chapter. We do quite a bit of factoring in the next chapter. So anyway, number 17, you're going to have to break it down like this in order to find the vertical asymptote. But to find the horizontal asymptote, we don't really want it like this, because we want to figure out, I mean, really, you don't have to do a lot of work. You don't have to multiply it all the way out, because you should be able to figure out what the degree of the bottom is. So what's the degree of the top one? Okay, it's a 1. I hate to even put a 1 because you're not really dividing these, but you do have a 1 on the top. What's the degree of the bottom? Like if I started factoring this out, what am I going to do? Do FOIL method, right? 2x times x, which is what? 2x squared. Are you going to have anything bigger than a 2x squared in here? No, that'll be your biggest one. So what's your bottom going to be? Now these are your degrees, okay? It's not a 1. That's your degree. It's a first degree and a second degree. So what do we say about this? What if the top is smaller than the bottom? Then your horizontal asymptote is always y equals 0. That's all you had to know. You just got to know which one's bigger, which one's smaller, all right? And only under one circumstance do you actually have to do any math, all right? Everybody good with that? So that's y equals 0. So that is your horizontal asymptote right there. Wow, way easier than what we were doing yesterday, wasn't it? Yeah, that's why I got so excited about it. All right, so that I gave you the first 3, and you have to go up to what, 23? Is that correct? Yeah. Yeah. Okay, does that help? Yeah. All right, so I'll let you do the rest. So 14 to 23. If it's the same degree, you do that division. Right, you divide the coefficients. Like the first one, right there. See, when they're the same degree, you take the coefficients of the largest exponents, okay? The degree of the largest exponents, and you divide them, okay? There you go. Yeah, let me show you one more thing. What if you had some, I'm just making this up. What if I had 2x over x plus 4, and then I had like plus 3? What does this plus 3 going to do to our graph? It's going to raise it up 3 places, isn't it? You follow me on that? Okay, so on this one, when you do the division, you get a 2, don't you? All right, but you still got that plus 3 there. So the horizontal asymptote is going to be y equals 2 right here, but then you still have to do what when that's on the end of it? You still have to add a 3. So what's your horizontal asymptote with that? It's y equals 5. All right? Because normally, if that 3 wasn't there, where would the horizontal asymptote be? It would be at 2, correct? But what does that plus 3 do? It moves it up 3 places. So if I'm at 2, it moves it up 3 places. That'll give me up to 5. Y equals 5. Does that make sense? All right, so look for that as well. All right? As long as that plus 3 is not like just like inside of the fraction. If it's outside the fraction like that, there will be some times where you have to add it to this. We good? All right, I'll let you finish that up. I'm going to try to find that video of that girl that kind of gives a good explanation of why these things are the way they are. And if you want to watch it, you can. I probably won't show it in here because you guys are working. So, all right, so that'll be due tomorrow. We'll go over that. And then we got one more lesson, okay? One more lesson. And it's a little bit of graphing, not too much graphing. It has a little bit to do with it. But it's more like regular math, all right, I guess, if you want to call it that, the next lesson, all right? So we'll probably postpone everything, okay? So the quiz, we'll probably postpone the quiz. So tomorrow we'll go over a couple of those things to review for the quiz, kind of tell you what's going to be on it and stuff. And we'll probably have the quiz either Monday or Tuesday of next week, okay? We'll see. Just be ready for it, okay? That's it.